You know that feeling, right? One moment you're thinking about AI, the next, bam, a whole new frontier just explodes into existence.
Yeah, it's exhilarating, definitely, but also maybe a little overwhelming.
Exactly. That's the pace of AI innovation. It feels like every week there's a new model, a new benchmark, some new buzzword.
Trying to keep up can feel like drinking from a fire hose sometimes.
Totally. So, our mission in this deep dive is simple: cut through all that noise in the 2025 large language model landscape, the LLM landscape,
Right. We want to help equip you, the listener, to be more of an AI strategist.
helping you understand the different models, what makes them tick, the benchmarks people use.
And crucially, how you can actually use them. Practical, powerful ways.
Think of this as your shortcut, your guide to who the major players are, what makes their models unique, and how to really harness their strengths.
It's like building your own elite team of AI specialists,
Yeah.
and you get to be the conductor.
We're going to unpack some surprising facts, give you actionable insights, so you can feel genuinely informed without getting totally bogged down.
We've been digging into the AI Strategist's Handbook, and we're excited to share some of the best bits.
Okay, let's dive in. The AI landscape, it's bursting with innovation, yeah, but it's really driven by a handful of titans.
The core members of that AI specialist team we mentioned each brings a unique superpower.
Let's start with OpenAI. They've often been the ones sort of defining the frontier, haven't they?
They certainly have, always pushing the envelope.
So OpenAI has this really interesting two-pronged strategy. On one side, you've got GPT-4o. The O is for Omni.
And that was a big architectural shift, right? A unified network.
Exactly, not separate systems. It's end-to-end, trained, natively processing text, audio, and images. It matches GPT-4 turbo performance,
The faster and cheaper.
significantly faster and 50% cheaper via the API. And the multimodality really shines with voice interaction, human-like response times.
Like 232 milliseconds.
Yeah.
That's incredibly fast.
It really shrinks that gap between human and AI chat, doesn't it? Makes real-time assistance feel actually real-time.
Changes the game for voice interaction completely.
And it also folded in GPT Image 1, replacing DALL-E 3 inside ChatGPT. Plus, a new tokenizer. This is big for global accessibility.
Ah, reducing tokens for non-Latin languages. That makes a huge cost
Yeah,
difference.
huge. Like 4.4 times fewer tokens for Gujarati, twice fewer for Arabic. Makes it way more affordable.
Okay, and context window?
128K tokens. So it can handle roughly a short novel's worth of info at once. Knowledge up to October 2023.
Got it.
And then there's GPT-4o Mini, smaller, faster, even cheaper.
Designed for those high-volume, low-latency tasks.
Precisely. Still beats GPT 3.5 Turbo, but the pricing is just wow. 1.15 per million input tokens, zero point 0.6 sus per million output.
An order of magnitude cheaper. That's significant for budget-conscious projects.
Definitely. Now, the other prong of their strategy, the O1 reasoning models,
Well,
O1 Preview, and O1 Mini.
this feels like a strategic pivot, focusing specifically on reasoning.
It really is. Engineered for advanced reasoning, using that think before you answer idea.
Like a chain of thought process.
Exactly. The model breaks down problems, analyzes them step by step. It uses more computation at inference time, but the output quality for complex tasks improves dramatically.
That think before you answer approach.
Yeah.
It's like giving the AI a scratch pad, right? Let it work things out.
Yeah, that's a great analogy. And the performance difference is stark.
I saw the numbers on that AME math test. O1 solved 83%.
Compared to GPT-4o's 13%. Massive difference. And it hit the 89th percentile in competitive programming on code forces.
That kind of reasoning capability is, well, it's state-of-the-art.
For sure. So you have O1 Preview for broad knowledge and O1 Mini, which is smaller, faster, 80% cheaper.
But more focused on STEM reasoning, less general knowledge.
Correct. And here's the catch. Those reasoning tokens, the internal thinking, they're billed as completion tokens.
So these reasoning models end up being several times more expensive than GPT-4o in practice.
Exactly. It's a premium feature.
That pricing structure really underscores their bet on reasoning. But it does raise a question, right? If you need that advanced capability, but you're, say, a smaller outfit.
How do you manage that cost?
Yeah. Or are there open source alternatives starting to bridge that gap in reasoning power?
Excellent point. Cost is always a factor. And while open source isn't quite matching the absolute top proprietary reasoning yet, the progress is incredible. Which actually brings us nicely to Anthropic.
Claude. They have a different vibe, don't they? Focused on reliability, safety.
Steerability, too. Their Claude 3.5 Sonnet is fast, powerful, and has some really neat features. It's the first in their 3.5 family.
Operates at twice the speed and lower cost than Opus, their previous top model.
And it's exceptional in vision, coding, and nuanced writing. It's their strongest vision model so far. Great at reading complex charts, graphs, even text from blurry images.
And the coding strength. 64% on that internal agentic coding test. That's a big jump from Opus's 38%.
It is. But you mentioned standout features. For you, it's artifacts.
Oh, absolutely. Artifacts isn't just window dressing. It creates this dynamic workspace next to the chat.
Yeah.
You can see, edit, build on the AI's output in real time.
So it's less prompt response, more collaborative.
Exactly. It feels like pair programming or co-writing with the AI. It transforms the interaction.
That real-time collaboration is massive for iterative work. Plus, a generous 200K token context window.
And the pricing.
Competitive, 3 per $1 million input, 15 per $1 million output tokens.
Okay. So shifting gears.
Yeah.
What about dealing with just massive amounts of data, where context is everything?
That's Google's territory. Their Gemini models, 1.5 Pro, 2.5 Pro, they're built from the ground up for native multimodality and that unparalleled long context understanding.
Native multimodality, meaning they handle text, image, audio, video seamlessly together.
Correct. But the real headline feature is that context window.
The 1 million token one.
That's the one, a genuine game changer. Just imagine.
You could feed it an entire code base to debug,
Mm.
or hours of video, or hundreds of pages of research papers.
All in a single prompt. Summarize a whole conference just by dropping in the recording. That capability is huge.
And Gemini 2.5 Pro added features like Deep Think for reasoning.
Using parallel thinking techniques, yeah. And native audio generation in 24 languages. Plus, adaptive thinking.
Where the model adjusts its effort based on complexity, and developers can set a thinking budget.
Exactly. Great for cost control and predictability.
Interesting. Okay, so that's Google's angle.
Sure.
What about Meta? They've taken a totally different path with open weight models.
Very different, but equally powerful. The Llama series, especially Llama 3.1, really proved open source can compete head-to-head with proprietary models.
Llama 3.1 brought improvements like a new tokenizer, 128K tokens.
More efficient encoding, yeah. And grouped query attention, GQA, for better inference efficiency.
And the context window jump was massive too, wasn't it? 8K to 128K.
Huge leap for open source, plus better multilingual support and tool use. But the really big news.
The 405 billion parameter model.
That's it. Proving open weight can absolutely achieve frontier performance. That's so important for fostering innovation beyond the big players.
And the permissive license is key too, allowing people to use the outputs to improve other models.
Creates a really vibrant ecosystem. Now, the practical side, running that 405B model locally.
Needs serious hardware, like an NVIDIA A180 GOAs, right?
At least, that's the trade-off. You get freedom, customizability, control.
Yeah.
But you need the compute power.
Makes sense. Okay, who's next? XAI Grok. That one definitely has personality.
Huh, a bit more personality, yes. Elon Musk's XAI. Grok's mission is distinct. Understand the universe, access real-time info, and yeah, that provocative tone.
The key strategic advantage seems to be that deep integration with X, the platform formerly known as Twitter.
Absolutely. That gives it a live, continuous stream of global conversations, news, data.
Which is incredibly valuable for things like real-time news summaries, trend analysis, sentiment monitoring. You get that immediate pulse.
For sure. And the personality.
Yeah.
Witty, rebellious, modeled after Hitchhiker's Guide to the Galaxy.
Adds unique flavor. That's what you need. Technical specs.
Grok 1.5 has a 128K token context window, and Grok 1.5V, the vision model, came with that real-world QA benchmark.
Testing spatial understanding of the physical world. Interesting angle.
Okay, next up, if you're a coder, this one might be your new best friend, DeepSeek.
Ah, yes. Known for coding proficiency, some clever architectural stuff.
That's their differentiator, pioneering designs. DeepSeek V2 uses a novel mixture of experts, MOE architecture.
Where only a fraction of the total parameters are active at any time, like 21 billion out of 236 billion.
Exactly. And combined with multi-head latent attention, MLA, for a compressed KV cache.
Which basically means it's much faster and needs way less memory for its size. It's efficient.
Dramatically so. It's like having a huge brain, but only lighting up the relevant bits for the task. And this translates to coding dominance.
DeepSeek Coder V2. That was the first open source model to beat GPT-4 Turbo on some key coding benchmarks, wasn't it?
It was. And it supports an incredible 338 programming languages, plus a 128K context window.
Wow, 338 languages. That's comprehensive.
And they also have the DeepSeek R1 family, pushing into advanced math, logic, programming. Performance getting close to OpenAI's o3 and Gemini 2.5 Pro.
Using distillation to make those capabilities more accessible in smaller models.
Yeah, smart strategy. Okay, now for someone a bit different, Perplexity AI.
Right, they're not building foundational models themselves, more like a really sophisticated answer engine.
Exactly. Their core product relies heavily on retrieval augmented generation, or RA.
And that's the key, isn't it? Tackling the LLM weaknesses like static knowledge and hallucinations.
Precisely. The RA architecture is its superpower. It doesn't just guess based on its training data.
It intelligently crawls, indexes relevant docs, augments the prompt with that retrieved info,
And then generates the answer with citations.
which makes it unparalleled for research, fact-checking, getting up-to-date, accurate info.
Totally. And it's model agnostic. The value is the RA framework. Pro users can even pick powerful backends like GPT-4o or Claude 3.5 Sonnet.
So you get the conversational ability of those models, combined with Perplexity's factual grounding. Best of both worlds for research.
Definitely. And finally, let's touch on Venice AI. They have a strong philosophical stance.
Right. Their focus is on open, transparent, decentralized AI for users wary of black box models or prioritizing privacy.
They offer a curated platform, access to a hand-picked suite of the best open source models out there.
Evaluated on things like performance, developer support, and crucially, minimal content restrictions.
Exactly. Models like Nuseta, Dog 70B, Llama 3.1 405B for text, Playground V2.5, FLUX for images.
So they act as a sort of vanguard for the open source movement, offering a clear alternative if you value that autonomy and transparency.
Precisely. Phew, that's a whirlwind tour of the major players.
It really is.
Hmm.
And if we connect that back,
Mm.
it's clear you've got this whole orchestra of specialized instruments, specialized power. But how do we compare them? How do we compare Grok to Gemini, apples to oranges?
Ah, yes. That brings us to the notoriously tricky world of benchmarks.
Tricky is putting it mildly sometimes.
Huh. You're right, it's complex. But understanding them is crucial if you want to get beyond the marketing headlines and really assess these AI specialists. Let's start with one you hear a lot about, LMS's chatbot Arena.
Often called the voice of the people, because it's crowdsourced, right?
Exactly. Blind tests. Users see responses from two anonymous models, vote for the better one, uses an ELO rating system, like in chess.
So it measures real-world conversational ability, general user satisfaction.
That's the goal. And top performers, consistently, are models like Google's Gemini 2.5 Pro, hold the highest ELO ratings.
There are limitations, aren't there? It's not a perfect measure.
Definitely not. There's the slop factor. Past a certain point, humans can get swayed by superficial things.
Like longer answers or more confident-sounding answers, even if they aren't actually better or more accurate.
Exactly. That's the slop. And then there's the data asymmetry problem.
The big players like Google and OpenAI just get way more head-to-head comparison data from the arena itself.
Vastly more, like 20% each. Which creates this feedback loop where they can potentially optimize for the test, raising fairness questions for smaller or open source models.
Okay, so Arena gives a general vibe, but with caveats. What about MMLU? That sounds more academic.
It is massive multitask language understanding. Think of it as the academic test. Comprehensive multiple choice across 57 subjects.
STEM, humanities, social sciences, professional stuff.
All of it. Usually tested zero shot or few shot, meaning the model gets little or no specific training examples for the tasks.
So it measures the breadth and depth of the model's knowledge from its pre-training.
Primarily, yes. And top performers here include xAI's Grok 3 hitting 92.7%, GPT-4o at 88.7%, and Meta's Llama 3.1405B right there at 88.6%.
Impressive scores. But MMLU has limitations too, right?
Oh, yeah. Data quality issues, like some questions having wrong answers in the data set, and it's super sensitive to prompting.
Like changing the phrasing slightly can make the score jump around.
Significantly. Plus, it's mostly an English benchmark. Good for knowledge recall, less so for deep reasoning or creativity, especially across languages.
Got it. So for the coders out there, there's Human Evil, the coder's exam.
That's the one. 164 handcrafted programming problems. Function signatures, doc strings, unit tests are provided.
And the metric is pass at K. If any of the K solutions the model generates pass the tests.
Right. Focuses on functional correctness. Top performers are OpenAI's O1 models, DeepSeek Coder V2, GPT-4o, often getting past at one scores over 80%, even 90%.
Which sounds amazing. But there's the puzzles to production issue.
Exactly. Human evil is great for foundational coding ability, but it's a bit like solving puzzles. It doesn't really capture real-world software engineering.
You mean dealing with huge code bases, dependencies, debugging existing complex systems?
None of that, which is why we're seeing a new generation of benchmarks emerge. SW Bench, where models try to fix actual GitHub issues. Big Code Bench, focusing on composing multiple function calls.
And performance on those is much lower, I assume.
Significantly lower. A model hitting 80% on human evil might only manage 40% on something like Live Code Bench, which uses more realistic scenarios.
So the benchmark numbers, you have to take it with a grain of salt. They don't tell the whole story. I've heard devs express frustration about that disconnect with real-world utility.
Absolutely. And there are other pitfalls, too, like benchmark contamination.
Where the model might have actually seen the test questions during its training.
Inadvertently, yes. So a high score might just be recall, not genuine problem-solving ability, which underlines the need for a portfolio approach.
Don't rely on a single number.
Exactly. You need a portfolio. Arena for general feel, MMLU for knowledge breadth, human evil for basic coding, maybe BAPQA for deep scientific reasoning. Look at multiple data points.
And the industry seems to be moving towards more custom evaluations, too. Meta benchmarks, human evaluation.
Definitely. Dynamic, customized evaluation is becoming key. Meta benchmarks that assess debugging or refining code. Lots of companies are building custom in-house evaluation suites using their own data and real use cases.
Because ultimately what matters is how well it works for your specific job.
Precisely. So, what does all this mean for you, the strategic user? It means ditching the idea of finding one single best AI.
It's about building that toolkit, that team of specialists.
Exactly. Choosing the right tool for the right job. This is where it gets really practical, where the rubber meets the road.
Okay, let's talk specifics. Creative writing, long-form content. Who's good?
Top recommendation there is probably Anthropic's Claude 3.5 Sonnet. It's often called the artisan's choice. Great with nuance, humor, natural tone. And that artifacts feature really helps the iterative writing process.
Makes sense. Any other contenders?
OpenAI's GPT-4o is a strong contender. Very versatile, coherent, reliable across many writing styles. And for an open-weight option, Meta's Llama 3.1, either the 70B or 405B, are powerful text generators if you want customization.
Okay. What about code generation, debugging, analysis?
For pure code generation, especially in open source, DeepSeek Coder V2 is our top pick. Undisputed leader there. Beat GPT-4 Turbo, 338 languages, 128K context, efficient architecture. It's a beast.
And proprietary option.
OpenAI's O1 Mini. Optimized specifically for STEM and coding, elite scores on human evil, code forces. But if you're looking at agentic coding...
Like the AI autonomously fixing bugs.
Yeah. Anthropic's Claude 3.5 Sonnet shows unique strength there. Its performance on SW Bench suggests it's really good for delegating whole development workflows, not just generating snippets.
Interesting distinction. Okay. Conference reasoning, scientific analysis.
Top rec there is OpenAI's O1 Preview, explicitly engineered for it. That think before answering process leads to incredible results on AIM GPQA, even beating human PhDs on some tasks.
Wow. Open weight alternative.
DeepSeek R1 is a strong contender, getting close to the top proprietary models. And Google's Gemini 2.5 Pro is a balanced option, very capable with its deep think mode and that massive 1M token context for reasoning over huge data sets.
Like analyzing an entire textbook for insights.
Exactly. Now, multimodal applications. Handling text, images, audio, video together.
Google's Gemini seems built for this.
Top recommendation, yes.
Yeah.
Gemini 1.52.5 Pro, natively multimodal, plus that 1M token context. Ideal for analyzing hours of video or transcribing meetings while looking at the slides shown.
Powerful combination. Other strong contenders.
OpenAI's GPT-4o, also unified multimodal, but its real standout is that super low latency audio interaction. Makes it premier for real-time voice assistance.
And for vision-specific tasks, like just analyzing an image.
Anthropic's Claude 3.5 Sonnet is often considered best in class there, especially for interpreting complex data visualizations, charts, graphs, real deep reasoning on visual information.
Good to know. What about bread and butter tasks? Research, summarization, data analysis.
Top recommendation is Perplexity AI Pro. That RG Cassandra engine is just in a league of its own for up-to-date, factual, verifiable info with citations. Directly tackles the hallucination problem.
Makes sense for reliable information gathering. What if you're dealing with really long documents?
Google's Gemini 2.5 Pro wins there, hands down. That 1 million token context window is the killer feature for processing entire books, legal contracts, financial reports in one go.
And for General purpose, quick stuff.
OpenAI's GPT-4o is a reliable workhorse.
Yeah.
Fast, versatile, highly capable for accurate text processing and synthesis.
Okay, last category. Cost-effective, high-volume, low-latency tasks, where you need speed and affordability.
Top pick is OpenAI's GPT-4o Mini, explicitly designed for this, an order of magnitude cheaper, perfect if you're making thousands of parallel or chained calls.
Open-weight alternative.
Meta's Llama 3.18b is excellent, great balance of performance and efficiency, and you can run it on consumer-grade GPUs.
And fastest vision model specifically.
Anthropic's Claude 3.5 Sonnet, again, operates at twice the speed of Opus, great for rapid image analysis or just fast, high-quality text gen when needed.
So looking at all these specific recommendations, it really drives home the point, doesn't it?
Oh, it's that.
That the real magic isn't finding one model, it's orchestrating this symphony of specialized models, each playing its unique part. That's where the true strategic advantage lies.
Exactly. The specialist orchestrator paradigm. You, the professional user, you become the conductor. Let's walk through a few examples of how that might look in real workflows.
Okay, practical examples. Love it.
All right, workflow template 1, the software development lifecycle. Step 1, requirements gathering and research.
Use Perplexity AI, right, for current, verifiable info on existing solutions, libraries, best practices. Leverage that RAG accuracy.
Precisely. Step 2, architectural design. Collaborate with OpenAI's GPT-4o or maybe O1 preview if it's complex to brainstorm system architecture, data models, API contracts, get a solid blueprint.
Then step 3, implementation. Hand it off to the coding specialist.
Got it. DeepSeek Coder v2. Let it generate the core logic, boilerplate code, leveraging its huge language support.
Step 4, debugging and refinement. This is where Claude 3.5 Sonnet comes in.
Yes, acting in its agentic capacity. Give it the code, the unit tests. Let it run tests, analyze failures, and autonomously fix bugs. Play to its SWE bench strength.
And finally, step 5, documentation.
Feed the finalized code back to Claude 3.5 Sonnet. Its natural writing style is great for generating clear, human-readable docs, re-adamas, inline comments.
Okay, that makes sense. A multi-specialist pipeline. What about something different, like marketing?
A good one. Workflow template 2, the content creation and marketing engine. Step 1, ideation and multimodal analysis.
Here you'd use Google Gemini 2.5 Pro, analyze briefs, images, customer interview videos. Use that 1M context window to pull out themes.
Exactly. Step 2, initial drafting. Feed those things to Anthropic's Claude 3.5 Sonnet. Leverage its nuance and creativity for a high-quality first draft of copy or a script.
Then step 3, editing and SEO.
Pass the draft to OpenAI's GPT-4o. Great for meticulous editing clarity, conciseness, grammar. And then use it to optimize for SEO, weaving in keywords naturally.
And visuals. Step 4.
Use OpenAI's GPT Image 1 via ChatGPT, or maybe an open source option like Playground v2.5 via Venice AI to create compelling visuals that match the campaign. Again, right tool for the job.
Makes sense. One more, business analysis.
Workflow template 3, strategic business analysis. Step 1, market research and data gathering. Start with Perplexity AI again.
Broad market scan, current trends, competitor news. Get that foundation of cited, verifiable data.
Right. Step 2, long document analysis. Upload those lengthy PDFs, financial reports, market analyses to Google Gemini 2.5 Pro. Use the 1M context window to ask complex cross-document questions, synthesize findings.
Step 3, synthesis and strategic brainstorming. Feed that synthesized data
to OpenAI's O1 preview. Leverage its advanced reasoning to spot opportunities, assess risks, formulate high-level plans.
And finally, step 4, presentation creation.
Turn to Claude 3.5 Sonnet's Artifacts feature. Generate a polished draft presentation or report and collaboratively refine charts, text, structure right there in the workspace.
These workflows really illustrate the power of orchestration, using each model's peak strength and sequence.
Exactly. Okay, so we've talked capabilities, we've talked workflows, but now we hit the big one. What does it all actually cost? And not just the sticker price on the API.
The total cost of ownership. Efficiency, environmental footprint. It's a crucial piece of the strategic puzzle. It's not just about the per token fee.
Let's break down API pricing first. Per token costs vary wildly. On the affordable end, you've got OpenAI's GPT-4o Mini, 0.66 per million output tokens. Like we said, an order of magnitude cheaper, great for high volume.
Mid-tier.
Anthropic's Claude 3.5 Sonnet, Google's Gemini 2.5 Pro, both around $15 per million output tokens. Good balance of capability and cost.
And an highest end.
OpenAI's O1 preview, reflecting that heavy reasoning computation. Its predecessor, O3, was $40 per $1 million output token. So reasoning costs a premium.
And open weight, like Llama. The cost shifts.
Right. Shifts to hardware, energy, hosting Llama 370B on AWS 2047 could be like $27,000 a month.
But there's a break-even point. If your volume is high enough, self-hosting eventually becomes cheaper than paying per token.
Exactly. But beyond raw cost, there's this efficiency imperative, optimizing inference.
Right, making the models run faster and use less resources. Techniques like model compression.
Yeah. Quantization is a big one, reducing numerical precision, like from 32-bit floats to 8-bit integers. Shrinks the model, speeds it up.
Pruning, too, removing less important parameters.
Yep. And knowledge distillation training a smaller student model to mimic a bigger teacher gets similar capability in a smaller package.
And you mentioned quantization-aware training, QAT versus post-training quantization, PTQ.
Right. PTQ is simpler, quantize after training. QET simulates quantization during training. It's more complex but gives more accurate results, especially important for running models on phones or edge devices.
Plus architectural tricks, like DeepSeek's MLA compressing the KV cache, or Meta's GQA reducing memory bandwidth needs.
All these little optimizations add up to significant efficiency gains.
Which brings us to the elephant in the room sometimes, the environmental footprint, the carbon cost of a query.
It's a big topic, and often misunderstood. Well, training takes a lot of energy.
It's the ongoing inference, the day-to-day use that's the primary contributor, like 65–90% of the total lifecycle carbon emissions.
That's what studies suggest. Now let's put some numbers on it. A typical GPT-4o query, around 0.3 to 0.43 watt-hours.
Which is tiny, right? Less than an LED bulb uses in a few minutes.
Pretty small. But those heavy reasoning models, DeepSeek R1, OpenAI O3, they can use over 33 watt-hours for one long, complex prompt.
Whoa, that's over 70 times more than a simple query.
Yeah, and generating a single AI image. Around 10–20 watt-hours, like
Right.
fully charging your smartphone.
So the individual costs can vary hugely depending on the task complexity.
Hugely. And then there's the paradox of scale. One query is small, but the global scale is staggering.
Like 700 million ChatGPT queries a day. What does that add up to?
Comparable to the annual electricity use of maybe 35,000 U.S. homes, and the water used for cooling those data centers, enough for 1.2 million people's annual drinking needs.
That's sobering. And the footprint depends heavily on where the data center is, right? The local energy grid.
Massively. The calculation is basically server energy use times power usage effectiveness, PUE, how efficient the data center is.
Google's are very efficient, like 1.09 PUE.
Right, times the carbon intensity of the local grid. So the same query run in France with lots of nuclear power has a way lower carbon footprint, maybe 81 grams of CO2 equivalent per kilowatt than in China, relying more on coal, maybe 1,057 grams per kilowatt.
Wow. So the location really matters for the environmental impact. And there's a direct trade-off between model complexity and energy use.
Absolutely, which leads to this idea of eco-efficiency. Claude 3.5 Sonnet actually ranked highly. They're a good balance of strong performance and moderate energy consumption.
Interesting metric to consider.
And here's one last really surprising efficiency factor, the cost of errors. Simple typos.
How do typos cost more?
It's all about tokenization. LLMs see text as tokens. Common words might be one token, strawberry, one token, but misspell it strawberry.
It gets broken down into smaller pieces, like straw and berry, or even individual letters.
Exactly, it fragments. And the core mechanism in these models, self-attention, scales quadratically with the sequence length, the number of tokens. Oh,
More tokens means way more computation, like double the tokens, quadruple the compute.
roughly, yeah. More tokens mean more computation, higher energy use, potentially even worse performance because the meaning gets fragmented. And
Then API pricing is per token. A misspelled prompt is literally more expensive to run.
bingo. So, providing clean, high-quality input, it's not just good practice, it's a critical optimization strategy for both cost and efficiency. Wild, isn't it?
That actually is wild. Never thought about typos having a direct computational and financial cost like that.
Okay. We have covered a lot of ground. You've just taken a deep dive into this really dynamic, complex 2025 LLM landscape.
And the clearest takeaway seems to be, there's no single best AI, no one-size-fits-all solution.
Absolutely not. Success hinges on a nuanced portfolio-based approach, thinking like that conductor building their AI orchestra.
So final recommendations for someone wanting to be that strategic adopter.
Okay, number one, abandon the search for a single best AI. Think virtual team of specialists. Each excels at something different.
Number 2, adopt a task-first, model-second mentality. Define the job clearly, then pick the right specialist model or models for that specific part.
Third, embrace that specialist orchestrator workflow we talked about. Break down complex projects. Assign tasks to the AI best suited. You conduct the ensemble.
Makes sense. Number 4,
Develop efficiency-aware practices. Consider API pricing, yes, but also inference efficiency, the impact of clean inputs, remember the strawberry problem, and maybe even the eco-efficiency of your chosen models. Align usage with your values and budget.
and finally,
Prepare for a future of AI agency. These tools are moving fast from being passive calculators to active collaborators. Your role is shifting more towards managing these intelligent teammates, not just giving commands.
that's a profound shift. Managing AI teammates.
It really is. Which leads to the final provocative thought for you, the listener. What does this all mean for your professional future? How will your workflow change when you start managing a team of intelligent AI specialists, not just prompting a single tool?
What new skills will you need to cultivate to really lead and orchestrate this powerful new era of digital collaboration?
Lots to think about. We hope this deep dive has armed you with some practical knowledge and maybe sparked some ideas. Keep exploring, keep questioning.
And keep leveraging these amazing tools. The landscape will keep changing, but hopefully you now have a better map.